Hello and assalamu alaikum everyone. I'm Dr. Afzal Badshah, and in this video series we will cover in detail the object-oriented programming. Before that, you have discussed the programming fundamentals and the fundamental to programming, how actually programming works, how we write the code, what are the basic structure of programming, what are the structure which are used to instruct the computer to perform some task, to instruct the computer to do some activities. Now we are going step further. We are going toward the object-oriented programming. This is the advanced level of programming fundamental, and particularly it is very important for the students who are related to the computer science. They are going to start their career in computer science or in the related fields, because the object-oriented programming is the code. This is the heart, not for your degree. It is also a code, it is also a heart for your skills too, because without that you will not be able to perform well in your future, in your career when you join any organization. Not a programmer, if you join the organization and any other aspects too, the object-oriented concept is also important there, because you will not be able to continue your career without understanding the object-oriented programming. And along with that, because nowadays we listen or we talk about that there is no future of the coding, because artificial intelligence is there, the large language models are there, and they are capable to code. We have to just learn the prompt. But the issue is, if you are not able to understand the basic of the coding, how they are structured, how they are modularized, what are the relationship between them, how they work, so definitely you will not be able to code or solve any problem or to debug any program, and definitely you will not be able to play. So artificial intelligence or LLM, ChatGPT or any other tool, they are they are assistant. You can use them if you understand the things. For example, you are running any office and you have number of employees there. So if you know the work yourself, you would be able to better run that office, because you know the work. You have different assistants, they are busy in the works, you are sending the task to them and they are working on that task, and collectively all of your team perform very well in that. Why? Because you know how to run the office, how to assign the task to each other, and if there is any issues in their work, you can assist them, you can guide them, you can debug them. So definitely object-oriented programming is very important, though there are different tools to code, but without the understanding of the object-oriented programming, you would not be able to code, to get any job, or to get any career in the computer science related skills. So why object-oriented programming? Why do we go from the programming fundamentals, why we go from the procedural programming towards the object-oriented programming? You can see this buzzword, this is the cloud of the words actually. For example, you are system analyst, you are software engineer, and you are sitting along with the university administration, and the university administration tell you the story that they need a software for their university, and the university should do all these functionality. The system should be able to register the student should be able to update their profiles, to check their results. Similarly, the system should be able to mark the student attendance, assign them the assignments, and similarly the system should also handle this and the record of the students, the university record. They should also facilitate the students and the teachers also. So you may listen you may listen about hundreds or thousands of functionalities the university administration may talk to you or may communicate to you. So in that functionalities, in these words, in these clouds, how would you be able to code, from where you will start, from where you will, and what type of functionalities or code you will assign to the team, what type of responsibility will you assign to the team. So it is very extremely. And for example, you code the program, and if you have coded, you may write a number of functionalities for a number of time. There may be some functionality which can be used for the teachers and can be used for the student, but you have coded that separately everywhere. And similarly, there may be a number of issues in that. And for example, if you code that, you may have different of issues in that also. There may be number of issues in that, there may be number of issues in the coding, and if you want to address these coding issues or functionalities issues, you will not be able to find the exact code that where you have coded for that functionality. As you can see that these are the clouds of word, these are the cloud of functionalities, these are the procedures to develop any software system. So it will be very difficult for you if you just write down the function, write down the needs, write down the demands of the university, that what they actually want. So it is extremely difficult to code if we see the problem from the procedural angle, from top to down approach, directly starting from the functions, that this is the function, this is the requirement of the people, or this is the requirement of the admin. So this will make the program very, very difficult. So what we can do, we can categorize the related functionality. For example, we can see, if we see to this cloud, we can see that some of the functionalities are related to the teaching. For example, taking class, assignment, providing assignment to the students, taking the student attendance, or taking the seminars. So we can understand that all these activities belongs to the teaching. These activities belong to the teachers. And similarly, there are some activities. For example, you can see that registration means student registration, sending some request to the university, solving the assignment, checking the updates, for example results update or admission updates. So we can group them together, and we can see that all these functionalities belongs to the student. And similarly, record management or facilitating the student and the teachers, we can also see that this can also be grouped together, and they may belong to any administrative issues or administrative post. And similarly, course allotment, etc., all these belong to the course. So instead of seeing this cloud in this format, which seems very complex, extremely complex, and it looks very difficult to be coded, and if we modularize it, if we categorize it according to the relationship, then we can see that this is a bit easier than this one. We can easily code that one, because this look in any modularization format, categorization format. And there may be a number of benefits. For example, I can say that the first part may code by one team, the second part may be coded by the second team, and third one, if there is any issues in that, then I exactly spot the issues. For example, the system is not able to update the attendance record, then we can see that this may be a fault, a problem of the teaching activities, because we have already categorized them, we have already modularized them. So this is very modularized, and we can easily debug, maintain, etc. And similarly, if there are any functionalities which is coded for the one module, for example something is coded for here and we need it here, so instead of writing it separately for the teaching activities and the student services or student activities, we can just reuse the code from the first one. So if we go from this figure, from this cloud, which focus only on the procedure, and we focus on that which organize all the functionalities in the module, then we can see that it is very easy to do. It modularize the task, it reuse the task, it convert into simplicity, and similarly we can easily debug that, we can easily maintain that. So if we further see that, if we take this photos a bit further, then we can see that the first module may belong to the teacher. We can say that this is a teacher module. All the functions which are related to the teacher, you can get them from the teacher. For example, teacher may take the classes, may give assignments, may take attendance, etc., etc. And the second cloud was, the second category was related to the student. For example, student can get registered, they may submit assignment, they may send other requests, etc., they may check the updates, etc. And similarly, the third one may belong to the any admin person who is facilitating in the record management, and the third belong to the course. So it make it very easy from taking that figure from that cloud to that one and then that one. So we can say that this is a modularized, everything is in its own module. Because it is in its own module, we can use some functionality from the other module if we need it, instead of coding separately to that. And any, if somewhere problem occurs, error occurs, we can easily debug that because it is in modularized way, and we know that from where this problem is coming. And similarly, we can easily maintain that everything is in modules, everything is in categorization, and we can easily module that. So this the travel from this figure to this figure, this is actually OOP, object oriented programming. So let's now introduce that what is object oriented programming. So I wrote that the object oriented programming in that format, object oriented programming. So you have to focus on the words. O means object, object means any real world entity. Look at the front, everything which you can see, all these are the objects. Your mobile phone may be object, the laptop may be object, the table, the chair on which you are sitting, the room, the house, everything are objects. So any real world entity which can exist, all these are objects, you know that. Oriented mean focused, centered. So that means that we should focus on the object, we should focus, we should be centered to the object. We shouldn't be centered to the procedure, we shouldn't be centered to the function. For example, you can see in that figure, in that cloud, all these which you can see here, all these words are actually functions, all these are actually methods, are the procedure which belong to any program. So instead of looking at that, object oriented programming say, look at that, only look at that, only the object. Look at the teacher, look at the student, look at the admin, and look at the courses. So instead of looking at that what the system should do, look at that what are the basic things, what are the basic entities, real world objects in your program. So we just write that the teacher, student, admin, and courses, this will be a part of the software, instead of focusing on that the procedures or the functions. So you can say in the object oriented programming, we start from the object, then we go towards the function, means we start from bottom to top approach, instead of starting from the function to object from top to the bottom. So object oriented programming means that the type of programming in which we will focus on the object, we will be centered to the object, instead of focusing, centering to the function, which is the main important part of the programming. So let's see a bit further that actually what is object in object oriented programming. Because we are studying the object oriented programming, we will cover a detailed course on that, a complete tutorial. So we must know that the what is object. Here you can see everything around you which you can see, all these are the objects. The chair can be object, the teacher can be object, the students are object, any bird is object, the laptop in front of you, that is object, the mobile phone which you are using, that is object, Any book or notebook which you have, that is object. You are a student, you are object. I'm a teacher, I may be object in some format. So all the real world entities are called object, and that object actually become a part of our program. So for example, in front of you everything is object, but what are the objects which play some part, which play some activity in your program? So when you were listening to the university administration, and they were telling to you that they need any software which will perform that task, so in that cast, in that problems, only that objects which were related to that problem, which were doing that function, which were performing some sort of activities there, or any object which have some responsibility there, all that will become the objects as a part of that software. So for example, if you are developing a university software, university application, and the university administration tell you a story, then in that story, for example, if you listen that story, I will take you back and to see that in that story there are a number of functions. The university administration is just telling you the story, that these are the needs, these are the requirements which we want to do, which we want to code, or which we want in our software. But instead of focusing in that, you just focus on that what are the main objects in that. When they were telling a story that their system should assign assignments to the students, the system should take or record the attendance, then the things which you are coming in your mind is the teacher, that there is a teacher behind that, the teacher is responsible for that. And similarly, when the administration was telling a story to you, that the student should be able to register themselves, they should be able to submit their assignment, and they should be able to check their attendance. So in your mind there was a student behind that which is responsible for that function. And similarly, they were telling you the story that the system should be able to keep the record of the students and teachers and everything. So in that, you know that there may be some person behind that, there may be some responsible object behind that, that is usually called admin. And similarly, they were telling in your story that that the courses can be allotted to the teachers and the students, and they can take courses in their semesters. So course was a object. So these are the things, these are the real world entities, these are the objects which actually taking part in your program. So let's check it further. So after checking that, you once again we come here in that slide, and here you can see that once we categorize the objects, we finalize that all these are the real world entities which are taking part in that program. Teacher, student, admin, and courses are going to take part in that program. Then we assign the related responsibility to the related object. For example, these are the functions which are related to the teacher, these are the functions which are related to the object, these are the functions which are related to the admin, etc, etc. So all this will make the program very easy. So at that time, I hope you know that actually what the object oriented programming means, what are the objects. And the second thing is why we are going from procedural programming, where we just focus on function, methods, and procedure, why we are going towards the object oriented programming. So this will answer us that why we are why we are going to object oriented programming. So let me correct it, because the main functionality of the object oriented programming is the modularization, because it modularize our program. So I will keep it in the first, because this is very important functionality of object oriented programming, and this is the main reason we go towards the object oriented programming, where the text went. Let me correct it. before the reusability we should keep the modularization, because this is a very important part of the object oriented programming. So why do we go towards the object oriented programming? As we saw in our slide, that our main purpose is to modularize the program. Look at that, this is very complicated, this look very complex, and we are not able to understand it. But when we look at that, or if we further look at that, then we can understand it that actually these are the some functions performed by some objects. So the basic purpose of the object oriented programming is we modularize the code, we modularize the functionality. Instead of putting then all the function in a single list, we modularize them, we put them in a different packages, we put them in a different you can see code blocks. And the second thing is that because we have modularized the code, we have modularized the functionality, it is very easy to reuse it. For example, we have code one module and we need that module some functionality in other module, then we can easily reuse that. And this functionality is not provided by procedural programming, where you just work on the function that what actually program should do. You just focus on the function, you just focus on the top to down approach, you are not focusing on the module, you are not focusing on the reusability. So object oriented programming help you not to repeat the code, because we are reusing it, we will not repeat the code. If we are not repeating the code, the program will not be complex, that will be easy, and that will also be easy to understand. So where the object oriented programming is putting our program into modules, it is also making the program to be reused, it is also avoiding to repeat the code. If you have coded this certain functionality, a certain uh, code for one object, you don't need to code for the second one. And the third one is it will make the program easy to maintain, because your program is in a module, you are not repeating the code, and if there is any issue, you want to debug it, you want to add some other modules, you exactly know that where the module is, how can you reuse it, you don't have any repeated code. So this make the program very easy to maintain or debug. And the third one is a flexible. Definitely program will be flexible if the program is in a module, program is reused, there is no repeated code, so you can easily take that program to use to debug and reuse, etc. So that is the reason, these are the main reason which make the object oriented programming very interesting, and which make the object oriented programming compulsory if we want to code for the large scales. So in the object oriented programming, the main next thing is a class. So if we are discussing the object oriented programming, we are discussing the objects, then what is a class? So I will take you to the one example, for example that one. So for example, this is a real world house. When we construct or build a house, before that we need a blueprint for that, we need any design for that. Taking an example, for example, the government is going to construct houses for the people, or they are going to construct hospitals or schools in the country. So directly constructing the houses, schools or hospitals, they must have any design for that, they must have any blueprint for that. So when the blueprint is designed, when the blueprint is created, after that the real house is created, the real school building is constructed, or the real you can say the hospital building is constructed, and the building or house looks exactly how the blueprint or how the design was made or how the design was prepared. The house looks exactly, if you have included two rooms in the design, the house will have two rooms, and if you have included three washrooms, the house will have three washrooms, etc., etc. So this is the exactly the thing which you have defined here. But the difference is, the blueprint or design is not a house. It is a virtual thing. It is just on a paper. These are just instructions to the developer. These are just rules and regulation. This is not a house. This is not getting a space physically on the land. Your land, you are not going to live in that. You just imagine from that design that the house may look like that, and when the house is constructed, then it exactly look like that. So once again, come here in our objects. These are our objects which we have created. So the issue is, before writing coding, the teacher, we must create a design for that, that how our teacher will look like, what should be its main responsibility, what should be its main characteristics in our system. We must have any design and a blueprint for the students too, because how will we differentiate the student from the teachers, what will be its main you can say characteristics, what should be its main responsibility, etc., etc. So all the objects which we have decided to include in our system, we must have any design for that, we must have any blueprint for that. So for that, the design which is used for any particular object, that is called classes. So in the classes, actually, which is a design, which is a blueprint, just like a blueprint for the house or design for any house, it is exactly designed, it is exactly a rules regulation, these are the principle, these are the blueprint, that how actually your objects will look like. Here you can, for example, you can say, if you have a person class, then you are going to store the person, then what are the attributes which you want to store for that person. For example, we name, age, gender and occupation, and for example you are creating the same for the students, then for the student we need the name, their marks, their semester, their department, etc., because the attributes characteristics changes according to the environment, according to the need of the software. And the second thing for the class is defining their characteristics, attributes. We also define their responsibilities, their functionalities, their methods, what are their main responsibilities in that particular software. So we defined uh, a template, we define a design for every object which we are going to include in our system. And once the class, the design or blueprint is designed, every object should look like that, or every object will put exactly the same data which is defined in the class, because this become rules regulations, you can't violate that. You will put the data, the object will perform exactly as it is mentioned in their classes, as it is mentioned in the design. So for example, if the person, you have included that particular attributes, so the system should be able to get only that, not the fifth one. And similarly, if you have included all these functions, then the person will be able to perform only that function, and this will not perform in another function. So what is object? Once you created a design, once you created templates for any object, for any real world entity, after that you start storing real world data in it. For example, we have defined a student class, and in the design and in the template and in the class, we write some rules regulations, that we will be getting the name, department, roll number, classes, that these will be the attributes of any class. And we also take that these will be the function, and they will be able to register, they will be able to forward some requests, they will be able to see their results. So after that, when the object is created, for example, one student A is entered, then the student A will have exactly the same attributes, same records, and they will have the same function, exactly as we talk about the house and the real world house and its map. As we created its design, the house, when the house was created, it was exactly the same as its house was, as its design was created. So in our world, when we construct our houses, we use the word design or template or blueprint for that. But in the object oriented programming, for that design, for that blueprint, for that principles or the rules regulation, for that instructions for the developer, we call that classes. uh, let's look at that table, because you are familiar with table. So so therefore I have placed one table over here, and in that table these are just columns. And for example, we define these columns that there will be write the student name, in the second we will write its roll number, in the third we will write its for department and classes, etc., etc. So you just define the rules, you just define the tables, but there is no data in it. But you know in your mind that as the table is structure, any data which will be put in that table will look like exactly as the tables are created, as the tables are designed. And after that, when we put data in that, you get exactly the same data for which the columns are created. For example, you get the name, you get the roll number, you get the department, and etc., etc., exactly as we talk over here. Then first we created a design, and then we created a real world house. In the classes, in the object oriented programming, we will have a class over here, and for that class we will have a real world object, for example a student. uh, Here you can see, for example, you create any class for the animal. So animal can be a class, and for that you take different type of animals. So the different animals will become objects of that animal class. Or you can see that if you create any class for the car, and in the car you define that what attributes or function you will create or you will need for that. And then when you have individual car data, then the cars are objects and your design is called a class. Or you can further see it, this will further clarify it because you are a student and you exactly know. The university organization defined one template design that for each student we will need its name, roll number, and grade, and they will be able to attend the class and submit the assignment. So this is actually the rules regulation. This is a design which is created by the admin. So every student, when in physically real world student is enrolled, they will exactly look at that, look like that design. So here you can see, as this is the class, as this is the design or this is the template, here you can see that this is a real world object. As we design here in the class that we will need name, roll number, and grade, exactly we now get the real world entity of Sarah. Her roll number is 12 and grade is A. Second, similarly you can see that here we get a second object, name, the student name is Ali, roll number is 5, and his grade is a 5. And similarly you can say that here is a third object, and the third object has the same data. So class is defined only once, and once it is designed, the object is created, or object is you can say defined exactly as the class was designed. We can't include anything extra over here because it is not included in the class. So object is the thing, it is the exactly the same copy as we define in the class. It is exactly the same house as we have designed for that. Hopefully the things will getting across, and you will be understanding that what is the difference between classes and objects, and particularly what is the object oriented programming. Here you can understand it in a better way. So class is defined by two things. We must know two things to define any class. uh, so everything around us are objects. uh, they become a part of any relevant program. For example, if you are developing software for the university, you are not creating any object or classes related to the house, related to the cars and doctors, etc. Though these are objects, these are the classes, but you are not going to include it in the university system, because in the university system they don't have any functionality, they don't have any responsibility. For example, doctor is an object, but doctor work responsibility is different, and you don't need any doctor in the university. And similarly in the hospital you don't need a teacher. So these are the different things. So in our university software, because we focus on the functionality, that if the functionality is coming there, we will make that object our class. When we were listening the story from the university administration, so in that story there is no any requirement or need related to the doctors. There is no any such related things. So you because there is no function related to the doctors, we are not making the doctor uh, as an object of our program. So class will have two things: the function. If the class has a related function in any particular program, then that will become a class or object over there, and we will define the full list of its responsibility, and we will also define its attributes. For example, in the case of the student, we will need its name, we will need age, gender, we will also need, because he is a student, we will need a department, roll number and semester, etc. And for example, if in the case of professor, we need its name, department, we will need the employment ID and its domain, etc. And similarly the students will have their own functionality. They should be able to register, check their results, update their profile, etc. And similarly some responsibility will belong to the teacher, for example teaching, marking the attendance, etc., etc. So class actually define, design, create a blueprint, create a template for the attributes of any particular objects and for the functionalities of any particular objects. So what are the attributes? Attributes are the data members. These are the characteristics which become a data member for any class. For in the case of person, name and gender, occupation, all these are the attributes. Look at that over here. For example, you are working on the laptop, then the laptop characteristics are, the laptop attributes are that what is the laptop brand, its model, its color, its name and prices. Because all these are the characteristics, all these are the attributes which actually define a laptop, and we understand the laptop from these properties. So all these are the attributes, all these are the data members. And similarly, laptop definitely have some function: turn on, shut down, open, etc., etc. All these are the functions. Function are method or action that object can perform, design insert class like attributes. So we define the attributes and object is the class level, and once they are defined, the object will copy exactly the same things. Up to that, we know that what is object oriented programming, what is the difference between procedural programming and object oriented programming, and we also know that what is class and what is the object, and particularly what is the difference between classes and object. Class is a design blueprint, and object is the real world entity of that class. I gave example of the design of the house and real world house. The design was first created, but this was not a real world house. There was no existing of it, you were not able to live in that. And when the house was created, that was the object which was exactly created as it was designed on the paper. So now we can go further, the key pillars of object oriented programming, and these are the pillars, these are the main functionalities, these are the main responsibilities which object oriented apply on the objects, on the classes. Because in the object oriented programming, we focus on the objects, we create classes, and to handle that classes, we apply these four different types of rules, regulations, all these four different types of principles or the pillars. So you can say that in the next, when we will start coding, we will apply these things on the classes and the object. For example, the first one is encapsulation, inheritance, polymorphism, and abstraction. So we will further shortly discuss that what actually these things means, how they are becoming the pillar of object oriented programming, and how they handle the objects and classes in the object oriented programming. Encapsulation, which is very important pillar of the object oriented programming, as the words show, encapsule, it means that we are putting the data in a capsule, and the reason for encapsulation is to protect the data, as we usually take the medicines capsules, and these capsules actually cover some medicines, and the reason is that the encapsulation actually protect that medicine from the outside world interaction. Exactly, we will need a capsule to protect the class. And what the class have? Class have variables, class have methods, as we defined over here, that in the class we have attributes, data members, we have the functionalities. So encapsulation will help us that nobody from the outside should get the data members and any function. So we will control that who should be able to access that data member and who shouldn't be able to access that member. So all these all these functionalities, all that protection, all these access control, that is called encapsulation, and this is very important pillar, this is very important part of the object oriented programming. And we will code how can we encapsulate our data to protect it from the outside world. And the third one is inheritance, which is also very important. Every pillar is important, but inheritance, because we discussed the modularization, we discussed the code reusability, and we also discussed that the no code will be repeated. The inheritance exactly do the same thing. The one thing which I forgot to discuss earlier in the object oriented programming is that object oriented programming actually mimic the same behavior as we observe in the natural world. Encapsulation, for example, in encapsulation, as we discussed earlier, this is the natural phenomenon. We hide some data, and we show some data to the people, we show some data to our relatives. So this is our natural phenomenon, that we want to hide some of our data from our relatives, from the other peoples, and there are some data which we want to show to our relatives but don't want to show to the other people. So exactly as we have this behavior to protect our data, to hide our data, to encapsulate our data, exactly in the real as we do have in the real world, the object oriented programming have the same behavior with the object in the coding world too, that this will hide some of the some data of the classes. The second one is the inheritance. As we have the inheritance in the real world, that we have parents and children inherit the properties of the parent. This may be physical property, that may be biological property. Exactly in the object oriented programming, we can inherit one class from the other class, and the child class will have exactly the same property as the parent class have, and definitely the child will also have some other properties too, as we do practice in our real world, or we see the same example in the real world, that object oriented programming, sorry, in the real world, the child inherit the property from the parent, and they do also have their own property. So exactly we will observe the same behavior in the object oriented programming too. This will minimize the coding, this will don't allow to repeat the code. And as we studied in the start, the basic properties of the object oriented programming, of the modularization and code reusability, etc., etc., so that will help us to reuse the code and avoid to repeat the code. As you can see, that animal some sort of functionality is inherited from the animal. Dog is also animal, cat is also animal, and they will inherit some properties for the animal class. Or you can see the vehicle, the motorcycle is vehicle, truck is vehicle, or car is vehicle, but we will define some functionalities which are same for all the motorcycle, truck and car, but they will also have some separate functionalities too. The third one is a polymorphism. Polymorphism, the word meaning of polymorphism is many forms. So it looks bit different. Encapsulate, as you can see here, encapsulation means that we are putting the data into the capsule. So the word encapsulation show that. Inheritance word exactly show the meaning and the functionality of the object oriented programming, that we are inheriting from one class to the second class. Polymorphism means many forms. So what do exactly many forms means? This can be clear over here, that for example you have an animal class, and in the animal class you have one function that is sound. But when you will inherit different classes from that, for example you inherit the dog, you inherit the cat, you inherit the dog, and when you call a parent function, for example sound, then the dog will bark, though you have a sound function, but the dog is behaving differently by barking. Cat is behaving differently by meow sound, and the duck is behaving differently by the quack sounds. So the behavior for same function is different. Or for example, for the same animal, and you have a function to walk. So if you have a dog, the dog will run. If you have any human, they will walk. If you have any frog, the frog will jump, and if you have a snake, the snake will crawl. So the subclasses have different functionality, they have different forms for the single function defined at the animal level. That is called polymorphism. The third one is abstraction. Abstraction, as the word show, we are actually showing the abstract instead of showing the complexity of the data, complexity of any class, its code. we just show the abstract level. For example, if you want for example, you drive a car, then you just have access to the control to navigate it, to brake it, to accelerate it, or to change the gear, but you are not aware how the engine works, how the mechanical physics is working behind that, how the gear is changed, and how internally the gearbox is working. When you press the brake, how the car stop, what is the basic science behind that. Or if you are using the electric system of that car, you just turn on the light, turn off the light, and turn on and off the different indicator, but you don't exactly know how and the things actually work behind that. So you just see the abstraction level, not the detail code, detail complexity behind that. Abstraction very help in the object oriented programming, because instead of focusing on the detailed program, instead of focusing on the complexity, we just work in the abstract level to make it easy. For example, if you are already coding in the object oriented programming and you write the cout, then it works. If you write the string and integer as you wrote in the programming fundamental, that it works. It declares the any variable as integer, declare the any variable as a string or character, etc. But the thing is how these things are declared, how the any variable become integer, how any variable becomes string by writing a single word integer or string. There is a complex code behind that. We are just using the abstraction as integer. We are not looking at the detailed code behind that, but there is some code behind that. And there is abstractions which hide all the complexities behind that. As another example is your phone. You use your phone, and you can see that any child of 2 or 3 years, they are able to use the phone. And then the people who don't know or read the English, they don't know about the programming, they don't know about the technology. Illiterate people who don't even read ABC alphabets, they still know how to run these apps, and how to run the Android. Why? Because the the engineer, the programmer hide the complexity. They show only the abstraction, they show only the GUI, and this is the reason the people are able to use the device, people are used to use the Android. And without that abstraction, it would be very difficult to use the same mobile phone by all the people. So this was short 1 hour, but you can say this was a short introduction to the object oriented programming. We will look at that in very detail our next classes, that how actually classes and objects are created, and how we apply different type of pillars, how we apply different pillars on these classes and object oriented programming. So we look at that in our next classes. But here is a task for you. You should sit here now, and you should consider a book. In object oriented programming, a book as an object. You should write a class for that. For book, you should write a class that what should be its attributes, what should be its data members, and what should be its classes, and other, can we apply any encapsulation for that? Should we need to hide some of the data of that book class? For example, if a book have name, its title, its any number, book number, and author, etc., do we need to hide some of its data, for example the prices? So you have to discuss all that, you have to draw all that. This is a class of the book, these are the attributes, these are the functions, and how we can apply any encapsulation or inheritance on that. So at the end, I will recap all the things that what we actually discussed in the object oriented programming. Object oriented programming, as we saw at the start, that object oriented programming actually focus on the object. Instead of focusing on the procedure, instead of focusing on the function, we just focus on the real world object. So everything around you is an object. And if someone is telling you a story about their software to be developed, then you focus on the object, that this person is talking about that object. These are actually nouns. So all your nouns become your objects, and you make them as a classes for your program. So this is a bottom up approach. You focus on the object, and then from object you get the functionalities. For example, first you decided that these are my objects: chair, teacher. You should look at that. These are our classes, for example, teacher, student, admin, courses. And after that you decide that the teacher will perform that function. These functions are related to the student, these functions are related to the admin, and these functions are related to the courses. And the second thing which we discussed, that why we go toward the object oriented programming. So the basic is modularization. We convert our program, we convert our complex problem into different modules. One is converted into the modules that can be coded very easily, that can be you can say debug or maintain very easily. And because these are in the modularization, we can reuse the code. Instead of coding different functionality for different purposes, we can write only one class, and during inheritance we just reuse the parent class functionalities for the children class. Maintenance is easy because the code the number of code decreases, the number of functions are decreases because we are not writing too much functions over here. We everything is in a module, so its maintenance is very easy, its debugging is very easy. If there is any bug in the program, then we can easily debug that. And similarly, all due to all that, due to modularization, due to usability, the program is very flexible in writing, in debugging, and in the maintenance. In the class, we discussed that the class is actually a design, and the object is a real world entity for that design. For example, you have created over here a design for the person, and for that person you decided that you will take this information. Or for example, you can say that you have designed one class for the student, and in that student you have decided that you will take all these data members and all these functions which are required according to the requirement, according to the story which was told to you. So you just created a template, you just created a design. So the design which you have created for that program, that is called a class. That's exactly similar as the design is created for the house. So this design is not a house, this not physically exists. These are just rules, regulation, these are just instructions for the builder, that how they should build the real house. Exactly over here, the class is a design, this is a blueprint, this is a template, this is not a real world house. These are just instructions to the developer that how they should code for any object. And when the real world object is created, all these real world object exactly looks like the class. In the class, the attributes which we have defined, exactly we have the same attributes, we have the same function for all the objects. Currently we have only 3 objects over here, but all these 3 objects have all these data members which we have already defined over here. And next we will look at that the 4 different pillars of the object oriented programming. In object oriented programming, we focus on the object, and for that object we create classes. So object and classes are very important, and the 4 different pillars are different rules, regulations which we apply on that classes and objects. So currently sorry, the 4 different pillars are encapsulation, inheritance, polymorphism, and Abstraction. Encapsulation means putting the data into the capsule, means protecting the data from the outside, controlling the data, that who can access that data and who can't. The third one is inheritance. Inheritance means that to inherit the parent characteristics to the children. So here the parent characteristics, data, member and functions will be inherited to the children instead of writing the program from in the scratch. And the third one is polymorphism. Polymorphism means different form, when same function behave for different objects for different classes. The dog bark, the cat meow, the duck quack, but the basic function is sound. And the last one is abstraction. Abstraction means hiding the data complexity, hiding the internal complexities, and making it easy for the users. So thank you so much, everyone.